Hello there and welcome back. On this video we're going to be putting the third rail on the back of this little 3018 to stiffen up the Z-axis actually. So we're actually going to put a third rail on the X-axis to stop the motor from flexing in the X-axis, which actually upsets the Z-axis as well. And to do that we're going to put this rail along the back here, and I've dismantled an old 3D printer that I had, an Anit A8, which I was never really happy with. So commandeered the parts of it, and this is the bracket actually for the extruder, and it's I'm using the bearings and actually the 8mm rail from it, and I'm going to actually put it on here and attach it to the back of the Z axis system here, just to stiffen it up, stop it flexing that way as much as I need to, you know, so I can run the larger tools and a little bit faster, you know, in feed rate. So I've measured up and 3D printed these brackets, okay, which is going to hold the rail and clamp it onto the back of here. So what I've got to do is, well, I don't require this part of the bracket, so I'm just going to slip that off, cut that off, and then assemble the rail and the bearing on here and clamp it onto the back of the Z-axis, or the X-Z-axis, mounting, and mark out where I'm going to put some holes and in this, and drill through into this. And I'll probably drill them together to make sure they match up exactly. So that's what we're going to do. Well, that wasn't difficult at all, actually. Brackets work perfectly. I mean, this is just a 90-degree bracket here with a couple of bearings on that I robbed from an old 3D printer. It's a very, very simple upgrade to stiffen up that X-axis. Well, more than sufficient for for this upgrade with the motor and everything. It's pretty damn solid now, and I believe it would cut aluminium. In fact, we'll give it a try during next week. So that's going to be it for this video today, because I know there's a few people waiting for these brackets, for the files for these brackets, which I will upload on my Patreon pages, and they are available with all the other 3D printed upgrades, such as this housing and the little laser housing to go in it, as well as, if I can find it, as well as this bracket. It actually would go in place in there if you wanted to use the aluminium housing. Okay, and if you are considering using the aluminium housing, this third rail upgrade is an absolute must. I think that the stepper motor will handle it okay. There shouldn't be any reason why it shouldn't. And of course this is the laser reducer then that fits in there when you take the motor out. So as well as now these third rail brackets over the back, and like I say, they're all available on my, well, as of this afternoon, which is Saturday here in Australia. This will be up on Patreon as well. I'll actually put these up on Patreon before I publish this video. So mechanically now this is complete. You know, we've done a lot of modification to this little 3018. There is only one job left, however, and that is to fit limit switches. Now I've got a couple of these limit switches and I'm one short, so I can't sort of video it today, but I sort of pre-thought this out. And another reason why I put this bracket here is because I'm going to mount this limit switch for the X-axis right on top of him there. I'm going to put a bracket off this bracket to come and touch and register the X home. And I'm going to put another switch over the back of here to register the Y, and of course up on the top of the Z there'll be another one there. So that will be the next video, and you know, that'll be out on Wednesday Australian time, Wednesday night, which is Tuesday afternoon, I believe, in the Northern Hemisphere, sort of UK, Germany, and of course the United States. So there we go. So what I'm considering doing, when I've done the on the next video, when I've got these all on, we'll do all homing, and we will do a nice 3D cut. Haven't decided what we're going to do yet, but it'll be a nice three-dimensional cut of art of some sort. And I have actually here a full set, as much as and a spare, actually, ER11 collet set. So here's the, now I got this as well, not that I'm going to use it. This is the actual ER11 collet. I got it actually for the extra nut, okay, because they do wear out with constant use, so it ended up being extra $2. So I thought, well, why not? And you know, why wouldn't you really? So, and again, where I get all my parts, like motor, power unit and what have you, is all on Patreon pages too. Now, of course, I don't know whether you can see this. This is in millimeters. That's a 1mm collet. Very, very, very small. I may use it one day. But it was actually cheaper for me to purchase a full set. That's a 3mm, equivalent to 1/8 of an inch. Yeah, this is the one I wanted. It's the one I really wanted, and I would advise you to get a set, because you never know when you want in between sizes. This is a 6mm ER11 collet, which fits in there, and of course this one is the 1/4 inch, or it will take a 1/4 inch end mill or a ball nose mill, which is what I really want to get in there. It actually goes all the way up to 7mm, but I think 1/4 inch is the largest cut shank that we want to put in this. Oh, get the right lid. Okay, so there we are. I'm really happy, really pleased, actually, the way that this has gone. And, you know, it all comes down, I suppose, to design. If you look at a problem, or find out what the problems are to a, you know, whether it be a CNC machine or whatever, and you look at it, I suppose, in a methodical way of, well, how am I going to do this? What's needed to be done? What's the minimum that it requires? And I always look at the minimum requirement, and then add a factor in of 50%. Okay, so that I always build, anything I do, I build sort of pretty biff, because it does pay dividends in the end. You know, you never get any problems with it. If you just do the bare minimum, well, chances are somewhere down the road you're going to, you know, it's either going to wear out or something's going to break. Because I have heard a number of people complain that the 3D printed unit that you can download off the Thingiverse breaks, cracks through. So to avoid that, I've printed this with a 75% infill. That means that, you know, the air gap in between here. Hexagon pattern, and I've left it open at the top to allow a little bit of airflow, and it turns out, well, if you look at this, is an injection molded one. Now, injection molded part is going to be stronger than a 3D printed part, but if you notice this, it's hollow. This is 75% solid. So that, and plus I've thickened up the walls, you know, all the way around, and especially where the bushes go. You know, that's nearly twice as thick at this back edge. So that is going to be a lot stronger than even this, because it needs to be. Because the motor is 3 times the power output of this. The motor it came with. This is 100 watts. That's 300 watts. And the torque of that is more than 3 times, actually. And the RPM is more than twice. I mean, it's operating RPM, normal operating RPM is 12,000. On the original one, it was supposed to be 6,000. So, anyway, I hope you've enjoyed the last 12 videos, actually, that we've put into this, and I've showed you every detail that I can. So, the next job is putting the limit switches on, and we'll do a 3D cut. I'm sorry I couldn't do it today because I've only got 2 switches. Okay, so please, if you've liked the video, please like and subscribe. And as mentioned in Patreon earlier on, I am retired now, and I don't produce anything out of this workshop other than videos for you guys. And you know, it would be a great help if you would like to become a patron, because it is the patrons behind this YouTube channel that really keeps it going and allows me to go and, you know, sort of purchase things like this, and you know, be able to modify and show you guys. So, thank you for watching, and it's bye for now.